Lathe. Constructional features and specification of lathe. Content covered. History of the lathe. Working principle of lathe. Construction of the lathe. Specification of lathe. A lathe is probably the oldest machine tool, stemming from the early tree lathe, tuned by a rope passed around the work a few times and attached to a springy branch overhead. Two dowels struck in adjacent trees or wooden support the work. The operator's foot supplied the motion, which was intermittent and fluctuating. The operator used to handheld the tool, but the early lathe was not useful for metal work due to lack of power and holding device. For its development to the form in which we know it now, we owe Henry Maudslay, who developed the sliding carriage and in the year 1800 built a screw cutting lathe. Nowadays, it has become a general purpose machine tool employed in production and repair work as it permits a large variety of operations. Now let's see the working principle of a lathe. Working principle of lathe. Lathe removes undesired material from a rotating workpiece in the form of chips with the help of a tool that is traversed across the work and can be fed deep in position. The tool material should be more rigid than the workpiece, and the latter held securely and rigidly on the machine. The tool can be given linear motion in any direction. A lathe is used principally to produce cylindrical surfaces, tapers, and bellows. Let's see the construction of the lathe machine. A lathe is a machine tool that holds the job between the center and rotates it on its axis. Due to this quality of holding the job from the center, turning is also called center lathe. A lathe bed is a rigid body that generally consists of a single casting. All the fixed and movable parts of the lathe are mounted on the bed. Headstock provides a means to assemble the work holding devices and transmit the drive from the main motor to work. The spindle is the part of the headstock which further connected with the chuck and faceplate. Work can be held on a chuck and faceplate. The part at the opposite side of the headstock is known as tailstock, whose axis is in line with the headstock axis. Carriage is located between the headstock and the tailstock. It is fitted on the bed and slides along the bed manually with a hand wheel or power feed. The saddle is an H-shaped casting with V-guide grooves at the bottom. Cross slide is mounted on the top of the saddle, which provides cross movement for the tool. Compound rest is fitted on the top and to the front of the cross slide, which can rotate 360 degrees. Apron fastened to the saddle, which houses gears and mechanisms required to move carriage or cross slide. Quick change gearbox contains several gears that provide feed rods and lead screws with various speeds. Specification of a lathe. It helps in communication between the seller and the buyer of the lathe. It helps the operator of the lathe to decide whether the work in hand can be accommodated by performing the operations. A lathe is generally designated by swing, that is, the largest work diameter that can be swung over the lathe bed, and distance between the headstock and tailstock centers. The size of a lathe is specified in any one of the following ways. 1. Bed length in meters, which may include the headstock length also. 2. The maximum length of work that can be turned between centers. 3. The maximum distance between headstock and tailstock centers. 4. Swing or maximum diameter that can be rotated over the bedways. Along with these primary specifications, following factors also help to designate a lathe, like range of spindle speeds, range of feeds, size of spindle bore, type of spindle nose. In this video, we have learned about a lathe machine's working principles, construction, and specifications. Thank you.